going to start this lecture by talking about how we graph equations by plotting points. In order to do this, we need to do some definitions first. An equation in two variables, say x and y, is a statement in which two expressions involving an x and a y are equal, just like in our equation here, y equals 3x plus 6. The expressions are called the sides of the equations. Any values of x and y that result in a true statement are said to satisfy the equation. The graph of an equation in two variables, x and y, consists of the set of points in the xy plane whose coordinates xy satisfy the equation. Now let's look at an example. Determine whether the points are on the graph of the equation 3x minus y equals 9. The 2 points we're going to look at are the points 3, 2 and the point 2, negative 3. For the point 3, 2, first we want to check to see whether x equals 3 and y equals 2 satisfies the equation 3x minus y equals 9. Let's substitute those values in for x and y, and we get 3 times 3 minus 2. That equals 9 minus 2, which equals 7. 7 does not equal 9. Since 7 does not equal 9, the equation is not satisfied, so the point 3, 2 is not on the graph. Let's do the same thing for point 2, negative 3. We're going to check and see whether x equals 2, y equals negative 3 satisfies the equation. So let's plug in those values for x and y. Doing that, we get 3 times 2 minus a negative 3, or 6, and a negative makes it a positive, so 6 plus 3. 6 plus 3 equals 9. So the equation is satisfied because 9 equals 9. So the point 2, negative 3 is on the graph. Now let's graph some equations. Let's graph the equation y equals minus 3x plus 3. The graph consists of all the points x and y that satisfy the equation. In order to locate some of these points, assign some numbers to x and then find the corresponding values for y. Let's make a table to keep ourselves organized. Now we need to fix some values for x. I always pick x equals 0 first. If I put 0 in for x, I get y equals 3. That gives me my first point of 0, 3. Next, let's pick a negative, so x equals negative 1. If I plug in negative 1 in, that gives me y equals 6. So my second point is negative 1, 6. The last example I'm going to do is a positive, so let's pick x equals 1. Plugging 1 in for x, I get y equals 0. So that gives me the point 1, 0. Graphing this way, you can pick as many points as you like, but you get the idea. Let's go ahead and plot those points on a coordinate system. By connecting these dots, we see that we have a graph or a line, and this represents the equation y equals negative 3x plus 3. Let's do one more, but change up our equation. So our equation is now going to be y equals 1/2 x squared. Again, we're going to start with our table. And I'm going to use the same 3 x values that I used for the last example, 0, negative 1, and 1. When you plug in those x values, you get y equals 0, y equals 1/2, and y equals 1/2 again. This gives me 3 points, the point 0, 0, the point negative 1, 1/2, and the point 1, 1/2. Plotting these points and connecting them with a smooth curve gives a graph or a parabola shown like this. The points, if any, at which a graph crosses or touches the coordinate axes are called the intercepts of the graph. The x-coordinate of a point at which the graph crosses or touches the x-axis is the x-intercept, and the y-coordinate of the point at which the graph crosses or touches the y-axis is a y-intercept. For a graph to be complete, it must show all of the intercepts. For this example, we're going to find the intercepts of this graph. So first, what are its x-intercepts? For x-intercepts, we know it's where it crosses the x-axis. So it crosses the x-axis here and here. This means that the x-intercepts are 3 and negative 4. Next, find the y-intercept. Well, the y-intercept is where it crosses the y-axis, and it seems to do that right here. That means the y-intercept is negative 3. We can also find intercepts from an equation. In order to find the intercepts, we're going to do a few different steps. So to find the x-intercepts, if any, of the graph of an equation, let y equals 0 in the equation. Then we're going to solve for x. To find the y-intercepts, if any, of the graph of an equation, let x equal 0 in the equation and solve for y. Our last example for this set, we're going to find the intercepts from an equation. Our equation is going to be y equals x squared minus 9. Let's find the x-intercepts first. Remember our steps from the previous section. Setting y equal to 0, we get the equation x squared minus 9 equals 0. We can factor that out into x minus 3, x plus 3 equals 0. And so we get the values of x equals 3 and x equals negative 3. If you're confused on that factoring, you might want to take a minute and watch the video on the difference of two perfect squares. Next, find the y-intercept. Again, let's pull our steps from the previous slide. This gives us an equation of y equals 0 squared minus 9, so y is going to be equal to negative 9. The x-intercepts are x equals 3 and x equals negative 3, and the y-intercept is y equals negative 9. Additional help for this section can be found by watching the videos A6 Solving Equations and A6 Quadratic Equations.